Okay, today in this video we are going over some pretty serious algebra stuff. So to start with, we have this idea of a composition, right? So we're still trying to do a composition, but it's a little bit different when we're given an equation, right? In the other video yesterday, we had talked about plugging this into a table and getting h of 4 from your table, right? That's the y value from your h graph yesterday, or your h table, at that x value of 4. Today, we're not given a graph, so we have to use the equation given to us for h. So we're going to first plug x equals 4 into the h equation. Okay, so plug x equals 4 into your h, and then we're going to get out a number. Okay, so that's what we do first. We find h of 4, which is 3/2 times 4 minus 2. Okay, so here we have some 5th grade fractional multiplication, right? When I have a whole number times a fraction, a whole number times a fraction, right? What is our process for multiplying whole numbers and fractions? So 3 times 4 is 12. 12 divided by 2 is 6. 6 minus 2 is 4. Okay, now I know it's the exact same number that we started with, but now we're going to plug that number into your g function. Okay, so whatever the y value is from h, you're going to take that and plug it into your g function, similarly to what we were doing yesterday with our tables. But today we have an equation that we're going to use to calculate your y value rather than a table that we're going to use to locate with our brains or with your eyeballs. So g of h of 4, doing that composition algebraically, gives me an answer of -7. Right? So anytime we are evaluating, you're always going to get a number for the answer. It's going to be a number. So number 2 says we are adding together two values. We want to know what is the y value from the f function when x equals -2. So let's calculate that. So f of -2 means we're going to take the negative of -2 squared plus 3 times -2 minus 5. Okay, so we're replacing -2 in for your x's, right? Just the x's. So you put parentheses around it and leave everything else there. Okay, so the negative is in front, our negative is in front. Okay, it's a +3, so it's a +3 minus 5, and so on and so forth. Okay, PEMDAS says, what do we do first? We do the exponent. So what is -2 squared? +4. Squaring something makes it positive. -2 times -2 is +4. Okay, but we still have the negative in front. Okay, that's still there. That's not gone yet. -3 times -2 is -6, and then -5 is still there. So now I combine all these. -4 minus 6 minus 5 is -15. Okay, so that's f of -2. Now the other one says, okay, what is p of 2? So we're going to plug 2 into your p equation. So you put a 2 in the numerator and a 2 in the denominator. So p of 2 is 2 plus 2 over 2 minus 3, which is 4 over -1, which is -4. So now that I have my two values, I have evaluated the f function at -2 and the p function at +2, I can add these two numbers together to give me my answer. So 15 plus -4 is -19. Okay, our third example is another composition. So we're going to first figure out what g of -1 is. So we're going to take -1 and plug it into your g function. So g of negative 1 is 1 minus 2 times negative 1. Right? What's negative times a negative? A positive. So 1 plus 2 is 3. So now our next thing is to find p of 3, right? Whatever that y value is from g of 1, we're going to use that to evaluate your p function. So p says, well, we're going to have to do some, there we go. 3 plus 2 over 3 minus 3, which is 5 over 0. What do we get when we get 5 over 0? No, we don't get 0. We get undefined. So we can write here that this is undefined, right? It's not equal to undefined, but it is actually undefined. Or you could write p of g of negative 1 does not exist, right? But there's no equals in there. There's no equals. It is undefined. Okay, so don't use the equals sign when we're doing an undefined or a does not exist answer. You just write the value does not exist, or the value is undefined. Okay, ready for some super awesome algebra? Me either, but we're going to do it. We're going to do it. Okay, find an expression for f of x plus 3. That means we are taking the x plus 3 equation or expression, and you're replacing all of the x's with it. We are replacing every x with what you see in parentheses. Okay, that is our standard procedure for evaluating these functions. So 2 times x plus 3 squared minus x plus 3 plus 3. Okay, so try and always put it in parentheses because we have this minus business, right? We don't want to just do minus x plus 3. It's minus all of x plus 3. Okay, so try and start off with parentheses anytime you're substituting an expression or in this case, a binomial, right? An x plus or an x minus in for a single variable. Okay, let's check your Algebra 1 skills. How is it done that we square x plus 3? Do you remember how to square x plus 3? Because it's not distribution. You don't just do x squared plus 9. That is not how we do it. You multiply it by itself. So let's come over here and do a little review. X plus 3 squared means x plus 3 times x plus 3. Okay, so x times x is x squared, and then we have a 3x and another 3x. So how many x's do we have in total? 6x. So 3x and 3x is 6x, and then we have a 9. Okay, so this is always the pattern that we're going to get anytime we multiply something by itself. You get the first term squared, you get the last term squared, but then you get double of the middle product. So what's 3 times x is 3x, and then double it to get you 6x. Okay, this always happens when we have a something squared. First term squared, second term squared. The product of your two terms doubled. So 3 times x times 2 gives you your middle term. Okay, that might save you some time somewhere down the road because it's not exactly fun, right? Doing it for so long. X squared plus 6x plus 9. Okay, let's distribute. This is going to be a minus x and a minus 3, and then a plus 3 at the very end. Okay, so can we do some simplifying? Sure, the minus 3 and the plus 3 can go away, right? Minus 3 plus 3 is 0. And now you have to multiply everything by 2, right? We distribute this 2 in here. 2x squared plus 12x plus 18, and then we still have the minus x. And now we have some like terms. 12x and minus x is 11x. So our final answer is 2x squared plus 11x plus 18. Right? There is a lot of algebra in there, a lot of simplifying, a lot of combining like terms and distributing. doing all of that wonderful stuff, step by step, right? It's meticulous, which is details, and is kind of annoying sometimes, but it is how we do this. Okay? So how about this second one? F of x minus 2 minus g of 2x. Okay? More algebra. So now we're replacing x with x minus 2 in those two places. And we're also replacing g with 2x, right? Just where the x goes, we're going to be replacing. So let's see what that looks like. So there is your substitution step. Okay, we're replacing all of the x's in your f equation with x minus 2, and we're replacing all the x's in your g equation with 2x. Okay, and now comes the fun part. All the algebra. Okay, pause and try to do it. I'll be right back. Wow, that is a lot of algebra. Right, so be meticulous, right? We got to be careful about the negative times the negatives. Over here, -2, -3, right? Be very careful. Minusing, we're minusing the 11 and the 4x, changing signs. Okay, when we're adding, right? Make sure we're adding the right terms. There's a lot of places where you could do one little mistake wrong, and then you have an entire mess on your hands. Okay, so be careful when you're doing the algebra. And this, y'all, is all algebra. It is very algebraic. Okay. Find an expression for this. Whew. Okay, this is a calculus thing called the difference quotient. And since this is a pre-calculus class, we're going to get you used to this because calculus is a whole bunch of algebra. Okay, so this is saying replace x in your g function with x plus h. And then subtract the original g function from it, and then divide everything by h. Okay, so let's see. We'll do this one part at a time. First, we're going to replace x with x plus h. Okay, let's see what that looks like. So here's what your equations, the numerators, should look like. We replaced x with x plus h. Okay, so that's our first part here in the red brackets. And then the second part is the original. So we're going to leave off the divided by h just to leave us some space. We're going to simplify all of this and then put the divided by h back in there and see what happens. So we've simplified it down to here. This is all of the stuff on the left minus all the stuff on the right. We distributed the minus into both of those. So now I have some like terms. I have 11 minus 11, 0. I have minus 2x plus 2x, also 0. So I am just left with this minus 2h business, right, divided by h. Okay, so remember, all this is still divided by h. So now we're putting the divided by h back in at the end just to save some space on our paper. So finally, what is negative 2h divided by h? Negative 2. That is fantastic. Okay, that it simplifies all the way down to that. So notice we had a linear equation that we started with. If we have a linear equation, right, with just x to the first power, you're going to get a numerical value as your final step. Okay. Now, let's look at this doozy one here. Now we're going to do the same thing for f. So take a deep breath. This is going to be kind of scary. So we do all that work to get to here. Now we have to identify your like terms. Okay, so we have a 2x squared and a minus 2x squared. There's a 0. I have a minus x and a plus x. There's another 0. I have a plus 3 and a minus 3. There's another 0. So all of those things cancel each other out. So I have a, let's see, what do I have? I have a 4xh. I have a 2h squared, and I have a minus h. So notice what all these things have in common. They all have an h term. Okay, and this is going to happen like 97.3% of the time, is all of your numbers and your x's are going to cancel each other out. and you're only going to be left with h things. Okay, so we want to divide this by h, right, because that's what our thing says at the top. So we've simplified your numerator, and you still have your divided by h. So like I said, all of these terms have a times h in them. So in order to cancel out your bottom h, we're going to factor, right, we're going to factor out the h. So we're writing h on the outside of parentheses. So we have 4x plus 2h minus 1. Right, when I factor in h out of each of these terms, right, the h is on the outside and the rest of your stuff is inside. So 4x, 2h, right, not 2h squared, but 2h, and then minus 1. Because traditionally, the h's should cancel out just like they do right there. Okay, that will almost always happen. In fact, it should happen every time the h's should cancel out to give you what looks like a linear equation, right, except for this h guy hanging out here. So in calculus, we'll talk about what happens when h goes to 0. So this term will go away, and you'll have 4x minus 1. Okay, so this is the beginning of a calculus derivative. It has all of this wonderful algebra in it. Okay, so let's see what else we got. Okay, so the back worksheet has more algebra on it. But look what we want to find now for A. Right, the first problems last time had a number in here. This time we don't have a number, but we have a variable. Okay, so if you start off with a variable in your equation, that means we're going to end with a variable. So we're trying to find an equation. This means take, or rather replace x in the g function, okay, because g is on the outside. So that's going to be your function that's getting replaced. So replace x in the g function with the h equation. We'll write h equation. Right? Because we're taking whatever is inside of the parentheses and we're putting that into g. Okay, so we're going to do a composition of functions. So we're going to take h, which is this equation, and we're going to replace it where the x variable is. Right? A second ago, we were doing this with a number. We were putting a number into an equation, replacing x with a number. Well, here, we're replacing x with an entire equation. Okay, this says take the g equation, and plug it in, take the h equation and plug it into the g function. So g says 1 minus 2 times something, right? That's what g wants us to do, 1 minus 2 times something. So that something is now going to be the h equation, which is 3/2 x minus 2. So we are replacing x with an entire equation. Replace x with an entire equation. And now let's do the simplifying. So minus 2 times 3/2, which is minus 3x, right? Because 2 times 3 is 6. 6 divided by 2 is 3. And then a plus 4. So let's combine our like terms. What is 1 plus 4? It is 5. So our final equation is 5 minus 3x. Okay, that's the equation that we get when we do g of h of x. Okay, what else do we got? G of f of x. So now we're going to take your f equation, which is this wonderful quadratic here, and you're going to replace x with that one now. Okay, so we are replacing a variable with an equation. So g is our equation, right? 1 minus 2 times something. We are putting the f equation in there, which is minus x squared plus 3x minus 5. So we're doing composition of functions. We are composing functions. We are taking one equation and we're putting that whole thing into a second equation and simplifying as much as we can. So negative 2 times negative x is a plus. Negative 2 times this is minus 6x, and negative 2 times minus 5 is plus 10. So then my like terms are the 1 and the 10. So my final answer is 2x squared minus 6x plus 11. Okay, so that is my functional equation g of f of x. Okay, so we can do that for these other two, and we can simplify their equations also. So let's look at our e function. It says do negative 6x times your h equation, and then subtract from that the f equation. So let's see what that looks like when we do all of our substitution. So after we simplify and distribute and combine like terms, we should get negative 8x squared plus 9x plus 5 as your equation. Okay, so then maybe our last one, for what values of x is f of x equal to g of x? So let's plug in these equations and see what we get. So notice we have an x squared term, which means we're going to make a quadratic. So we're going to get all of your terms onto one side, keeping the x positive, which is why we're going to the right side this time, so that we have a positive x squared value. Okay, so we keep x squared positive, so everything becomes on the right. Wait, I got to go here. This is a 6. That's right. So let's factor. What numbers multiply to give you 6 and add to give negative 5? Okay, they are negative 3 and negative 2. Right, so negative 3 times negative 2 is positive 6. Negative 2 plus negative 3 is negative 5. So we're setting our equations equal to 0 and solving, and you'll notice after we do this 5,000 times that the solutions are always opposite. So if you have an x minus factor, you have a positive 2 solution, and here's another minus 3 factor, you have a positive 3 solution. Okay, so with these compositions, there is a lot of algebra to be done. Just be careful when you're distributing and combining, especially with negatives, because that's where students make the biggest mistakes. Have a swell day.